Hi and welcome back to Wobblycogs workshop. If you've been watching my channel for a while, you know that there's a problem with my workshop. It doesn't have any lights. Well, in this video, I'm going to fix that problem. The new kid on the block for lighting is this stuff, LED strip or ribbon. So you buy LED ribbon in reels like this. They're normally 5 meters long. And all the ribbon is a flexible circuit board with surface mount LEDs and resistors for current limiting. On the back you normally get a sticky tape, but it's not normally terribly sticky. When you buy an LED tape, there's 3 variables to watch out for. There's the type of LED, there's the number of LEDs per meter, and there's the voltage that it runs off. So this tape is a 5630 LED with 60 LEDs per meter, and it runs off 12 volts. So if you have a look at the label on the packet this reel came in, you'll see all the common options. You'll see there's 12 volts and 24 volts plus specified. 12 is by far the most common. 24 is becoming a little bit more common, and in some respects it's more useful, I think. Next you have LED type. So you've got 3528, that's a very small LED. It's good for sort of incidental lighting, not great for room lighting. There's a 5050, which is a slightly larger chip. That you can light a room with a 5050. That gives out a decent amount of light. And then at the end here you've got the 5630, which is what this tape is. 5630 is good for lighting rooms, but it does run a little bit hotter. There's also a 3014, that isn't terribly common. Next you've got LED quantity. This is the number of LEDs per meter. It really, in my experience, is dependent on the size of the LED chip. So like with this 5630, it's pretty much always 60 LEDs per meter. With the smaller one, the 3528, you do get various number of LEDs per meter, sometimes 120, sometimes more or less. That one's quite variable with the smaller chips. So next up is colour. I'm only going to focus on cool white and warm white. This reel is a cool white. It means it's got a lot of blue in it, so it's a very high temperature. You can get a warm white as well, which is mimics an incandescent a bit more. I think the cool white looks better in a workshop, gives you a truer representation of the colours. Cool white is also fractionally more efficient than warm white. Next you've got waterproofing, so you can get this tape with like a resin or a silicone cover on it. Questionable, I think, how waterproof it is. It's certainly splash proof rather than waterproof. So at its most basic, powering one of these ribbons is just a matter of connecting it to a 12 volt source. As you can see, I've set my bench power supply to 12 volts and 1 amp. This ribbon would take more than 1 amp, but I don't want to swamp the camera. So if we just turn it on, see, we get light out. So when you drive an LED, you should do so from a constant current source, but because the ribbon comes with resistors built in, we can use a much easier to get hold of constant voltage source, and you can pick up 12 volt sources from just about anywhere. Powering LED ribbon is as simple as providing 12 volts. You can get 12 volts from any number of sources. One obvious choice is a car battery, which typically provides about 12 volts. You can get some lithium ion power banks like this that have a 12 volt output. You can obviously buy dedicated 12 volt power supplies, but if you want to go a little bit cheaper, you can go for something like this, which is an old computer power supply. These have 12 volt outputs. The black is neutral and the yellow is 12 volts. You have to play around with them a bit to get them to work. Here you can see I've put a jumper between the green and the black, and that tells the power supply to switch on. So you've got to be a little bit careful when using a computer power supply, because the rated power is not the power it can provide on 12 volts, which is what you're interested in. This one, for example, let me just zoom you in. So this one is 650 watts, but you'll notice that on the 12 volt rails it can only provide 465, and I would actually say it's questionable whether it can provide all that. And not only can it only provide 465, it's across all of these yellow and black pairs. You can't just expect to get the full 465 watts down one pair of yellow and black wires. You're going to have to gang these wires together to get all that power out. Another problem with using a computer power supply is that they often don't regulate properly, and what you'll need is a small resistor, typically say 10 ohms, and a few watts, and you'll need to put that across the red and the black. That's 5 volts. that will cause the circuitry in the power supply to then regulate the output voltage correctly. In my experience, older power supplies tend to need this. Newer power supplies will typically regulate correctly on their own. But you know, a resistor like this, you know, it's a quid or £2 or something off eBay, so it's worth just getting one just to test. I've just made up here, this is an old Molex connector, so an old computer connector, and I've just chopped that off and crimped a couple of connectors on. So I've got a 12 volt supply out here for testing, and I can regulate there, and I've still got the old Molex there. So I've covered the basics of providing power to the LED ribbon there. The long and the short of it is you need to provide 12 volts DC. Now, the next problem is actually providing 12 volts DC. So if your LED ribbon is sitting right next to your bench power supply that can provide 12 volts and however many amps you need, then everything's easy. In reality, that's not the case. In reality, your LED ribbon is on your ceiling, and it's often quite a distance from the power source. So here's a SketchUp model of the ceiling in my workshop. This wall here is about 5.2 metres, and this one's about 6.1. The power supply for the lights is here, and the power runs down here, along there, and up the centre of the room. So, given that, let's call that 5 metres, call that 2.5, and there's a bit here. So you're talking nearly 8 metres from there to here. So if you go online, you'll find voltage drop calculators that will tell you what voltage drop you'll get between, say, a power supply and the end of the cable, based on the cable thickness, the cable type, the voltage, the current, and all the other parameters that matter. So if you start plugging in the numbers, you'll find that running 12 volts from here to here with a reasonable voltage drop, it's just not going to happen. For, say, a copper cable, it was coming out something ridiculous, like 96 square millimetres. Now, in reality, yeah, you'd only need really thick cable from here to here, and then you could step down the cable sizes as you went along. But these are ridiculous cable sizes to get this, to not suffer the voltage drop. So the solution I finally settled on was to put a 24 volt power supply here, and then put buck converters in each one of these little grey boxes. I like this solution because it means I can use reasonable cable sizes. Like this first run here, I'm probably going to do in 6mm, but then these can be 4mm and these probably 2.5mm. Of course, the downside of this system is it is a bit more complicated. You know, I've got 6 buck converters in there, but you know, they don't cost much. So I think I bought them for £4 each, so you're talking 25 quid in buck converters. So I'd be really interested to know what people think of this as a solution. I'm guessing most people would just run mains voltage along here and then just use separate power supplies. But as I say, I wanted a low voltage distribution system, and this seems to be, you know, a simple low voltage distribution, and it gives you exactly the voltage you want where you want it. So the system I'm going to use for my workshop is actually very similar to the lighting that's actually being used for this video. So what I've got here is an old laptop power supply. This provides 19.5 volts, and I'm running that through here to this, which is a buck converter, and then that's going off to 2.5 metre strips of LEDs that are illuminating this scene. So I've got this set to 12.5 volts at the minute because I'm just soak testing the LEDs, make sure they are more than happy with 12.5 volts, and they seem to be. I've actually run them higher. I've run them at 13 volts, and they seem happy with that as well. So on my lighting plan, I had little grey boxes, and this is one of my little grey boxes that holds the buck converters. Basically, all it is just somewhere to keep the buck converter that keeps it neat and out of the way and stops too much dust ingress. So inside the box are all the pieces I need in order to connect up one set of LEDs. So I've got a couple of 20mm conduit connectors, a buck converter, a couple of Wagos, and for actually connecting to the LEDs I'm going to use just 2.5mm jacks. I'm also optionally I'm going to install a fan, and there'll be a filter across it. So I've tested one of the buck converters bucking 24 volts down to 12.5 for the LEDs, and it does get slightly warm. I don't know whether I'll need a fan, but I thought I'd buy them anyway. I mean, they're like 50p or something. I'm going to make up one box with a fan just to see how it works. If it turns out I don't need a fan, then I've not lost anything. These 2.5mm connectors are good for 3.5 amps, which is enough, more than enough, to run one of the LED strips. Because of the voltage drop on the strip, I'm actually only seeing about, well, less than 2 amps per strip. So that's more than enough, and that will go in the side and make a nice simple connector. So that's as far as I've got so far. I'm still waiting for my 24 volt power supply to arrive from China. I ordered it just before Chinese New Year, which means it's taking forever to get here. I'd be really interested to hear thoughts and comments on this build. It's not an idea I've seen anybody use before, which always makes me a little bit nervous, but I can't see any obvious flaws to it. I think it's going to work pretty well. But until next time, bye.